maths videos with Miss Riley and Yoda, and we're looking again today at questions involving the area and perimeter of parts of circles, or sectors as they're called, and also the length of arcs. So I'm working through Texts and Tests, page 119, exercise 6.3. A previous video looked at questions 5, 6, 7 and 8, and this video is dealing with questions 9 and 10 and 11. So I'm going to fly through them a bit more quickly here. We've got a piece of pizza here. We're trying to find the length of the perimeter. So it's very like the ones we've been doing. We've got the length of the arc. Arc is going to be 45 over 360 times 2 times pi times r. So 45 over 360 times 2 times 3.14 times 14. So what's that? 1/8 times 2 times 3.14 times 18. So whatever that is. 1 divided by 8 equals times 2 times 3.14 times 18 equals 14.13. 14.13 centimeters. And then we have the radius of 14. So altogether it's 14.13 plus 14 plus 14 plus 14 plus 14. So 42.13 centimeters is the length of the perimeter of the pizza slice. Okay, so just to use the highlighters to help with that, this is the arc, that's that, and then you've got to add on the 14 and the 14 to get the full perimeter of the shape. Okay, here's our pizza box. We're asked then if this pizza fits exactly into a box. So I've drawn the whole pizza here. Here's the box. Find the area of the unused surface. So we're trying to find the area of the unused surface of the box. So that's this area here. So the area of the unused surface is going to be the area of the box minus the area of the pizza. Okay, so the box is a square, and the box has a, oh, it's a bad square, but anyway, the box has a width of the diameter of the pizza. Okay, and the radius of the pizza was 14, so the box has a width of 28. So 28, so the area of the box is 28 times 28, which is 28 times 28 is 784 centimeters squared, and the pizza has a radius of 14. It's pi r squared. That was length by length, by the way, of course, for the area of the box, length by length. The pizza is pi r squared, which is 3.14 by 14 squared, which is 3.14 times 14 squared, which is 615.44. So the shaded area is going to be 784 minus 615.144. 784 minus 615.444 equals 168.556, and we're asked to give it to 2 decimal places, so 168.56 centimeters squared is the unused surface. So about about a fifth, just under a fifth of the box is not used by the pizza. Okay, the next question, question 10, speeding up again. So we've got to find the area of these shapes. These are the 3 shapes we're given. We're told that this is 22 centimeters for the diameter, so 22 divided by 2 is 11 centimeters for each of these. So the area is going to be how much of a circle? How much? It's going to be 180 over 360, so it's half of a circle, isn't it? It's a semicircle. So the area is going to be 1/2 by 1/2 by pi r squared. Area is pi r squared for a full circle. So it's going to be 1/2 by 3.14 by 11 squared. So 0.5 times 3.14 times 11 squared equals 189.97. And to one place of decimals is going to be 190 centimeters squared. Okay, that's for the first one. This one that looks a bit like a pram. Sorry, bad drawing. This is a right angle, and this is 8, and this is 8. So how much of a circle? This is 270 degrees, if that's 90 degrees, and the whole lot sums up to 360. So we've got 270 out of 360 times pi times 8 squared. So 3/4 times 3.14 times 8 squared. 0.75 times 3.14 times 8 squared equals 150.72 centimeters squared. So 150.7 centimeters squared for that area. This area is a bit more challenging because we have two parts. We have a semicircle. So 1/2 pi r squared. This is 16. So the radius is 16 over 2, which is 8. So 1/2 by 3.14 by 8 squared, which is 0.5 by 3.14 by 8 squared equals 100.48 centimeters squared. So 100.5 centimeters squared. And then we've also got this rectangle, which is 16 times 9. So area equals length by width, which is 16 times 9, which is 144 centimeters squared. So the total area equals 105 plus 144, so 244.5 centimeters squared. Okay, I hope that makes sense. You can always go back over the video and slow it down if I've moved too quickly. Okay, this question here now is very challenging, I think, but what's challenging about it is just trying to understand what they're saying. So let's just quickly take an image of it and talk about it, and then we'll talk through how we'd solve it. So you've got a running track. Let's get a pencil. You've got a running track. A running track's in the shape of a rectangle. Here's the rectangle with semicircular ends. Calculate the length of the inner lane of the track. So the inner lane of the track, I think they're talking about here, is the track 1, which you can just about see. If you zoom down, let's see. So this is track 1 here. Do you see it? This brown, this inside brown lane. Okay, that's the first part. We'll talk about how we'll do that in a second. And then track 2, 3, 4, and 5 are the next 3 tracks. 2, 3, 4, and 5. 5 looks a bit weird, but I don't think they mean it too. So if each lane is 1 meter wide, calculate the length of each lane. Hence find the length of the stagger, so that after 1 lap, each runner will have traveled the same distance. So the stagger, well, we'll have to look at that. I'm not sure that's very clear. And how many laps would an athlete have to complete in a 10,000 meter race? So I guess what they're saying is, I think actually normally the lanes would go this way, because that would deal with the stagger. But anyway, what we might do is check the answer and see what they're asking us. Okay, so that's the question. If you keep the question out in front of you there, and we'll talk about it. I'll keep it out in front of me here. So what I've done is I've drawn the first, the inner lane of the track. So let's see, we've got, let's draw that again here then, over here. So here is the shape. We've got a rectangle, and then we've got a semicircle at each end. Okay, we're told that this is 63 for the green and white part. This is 101. and this is 101. Okay, and this is 63 here. So I reckon for the first lane, you've got 63 plus 1 plus 1. So I reckon you've got a diameter of 65. So it should give us a radius of 63 divided by 2 plus 1. Okay, which would be either that or 65 divided by 2, which should be the same thing. So 63 divided by 2 is, you can't see that, is 31.5 plus 1, which would be 32.5 meters. So the radius of track 1, radius of lane 1, is either 65 divided by 2 or 32.5 meters. Okay, so the circle, which is made up of this end and this end, will be 2 by 3.14 by 32.5. Okay, so 2 by 3.14 by 32.5, 2 by 3.14 by 32.5, which is 204.1 meters for the end bits of the circle. Yeah, so this is 1 and this is 1, this is 1 and this is 1, and then you're going to add on 101 plus 101. Well, that's going to give us too much, isn't it? So actually this must be lane 2, the perimeter of lane 2. Maybe lane 1 they count as if you're running down the straight edge of the inside along here. So let's say this might be lane 2, which 204.1 plus 101 plus 101, which is 406.1 meters. That must be lane 2 actually, because I suppose we're counting the inside line of the lane. Okay, so lane 1, let's go back over here to look at lane 1 then. We'll have a radius of 63 over 2, which is 31.5. So it's again this end and this end, two semicircles make up, so that's a full circle of radius 31.5. So it's going to be 2 by 3.14 by 31.5, 2 by 3.14 by 31.5, which equals 197.8 plus 101 plus 101 plus 101 plus 101 equals 399.8 meters. Sorry about that, 399.8. So what they're saying, I guess, then is that each other lane is bigger than that. So if each lane is 1 meter wide, calculate the length of each lane. So lane 2 has a radius that's 1 meter more than 31.5. So we've done that, has a radius of 32.5. Lane 3 is going to have a radius of 32.5 plus 1, which is 33.5. Lane 4 will have a radius of 33.5 plus 1, which is 34.5. So let's just work out these radiuses again. The inside lane 1 is 31.5 plus 1 is 30 plus 1 is 32.5 for lane 3. 31.5 plus 1 plus 1 plus 1 is 34.5 for lane 4. 31.5 plus 1 plus 1 plus 1 plus 1, which is 35.5 for lane 5. Okay, so what I've got here is lane 4 is 34.5 and lane 5 is the radius is 35.5. So the length of lane 2 was 406.1 meters. The length of lane 3 is is 2 pi r for the circle, which is 2 by 3.14 by 33.5. 2 by 3.14 by 33.5, which equals 210.38. And then we have to add on plus 101 plus 101 equals 210 plus 202. Sorry, I didn't allow much space, but I'm not going to go back and do it again. So 412.88. 412.88, and then lane 4 has a radius of 34.5, so the full circle is going to be 2 pi r, 2 by 3.14 by 34.5, 2 by 3.14 by 34.5, which is 216.66. plus the 202 for the straight bits, so that's 418.66. so we seem to be going up in sixes each time, do we? Anyway, roughly. And then lane 5 will be 2 by pi by 35.5, which equals 2 by 3.14 by 35.5, which is 222.94 plus 202 again. What's that? So 424.94 meters. So what we have here, very complicated question for the middle of an exercise, but anyway, what we have here is that lane 1 was 399.8 meters, lane 2 was 406.1 meters, lane 3 is 412.88 meters, lane 4 is 418.66 meters, and lane 5 is 424.94 meters. Whew. So hence find the length of the stagger, so that after each lap, after one lap, each runner will have traveled the same distance. Of course, I think they've drawn this diagram incorrectly. I think we run normally in an athletics track. Do we start here? Or maybe we do. I thought we ran this way in an athletics track. Anyway, so they're obviously, this is the stagger here that they're talking about, this line. So they've all done one loop. I'm sure that's going the wrong way. I'm sure you run down this side to finish. But anyway, so the stagger looks like it's going to be have to be 6 meters, doesn't it? The stagger is going to be the gap between the lengths of each lane to make it 400 meters, because as you know, an athletics track should be 400 meters. So this is roughly 6 meters, roughly 6 meters, roughly 6 meters, roughly 6 meters. So the stagger is going to be 6 meters each time, approximately 6 meters each time. And I'm not going to work those out in detail. How many laps would an athlete have to complete in 10,000 meters? So if the race is 10,000 meters and each lap equals 400 meters, then the total number of laps is going to be 10,000 divided by 400, which is 25, isn't it? Let's just double check. 10,000 divided by 400, which is 25 laps of the track. Okay, I didn't like that question at all. It's very bitty, and they probably thought they were being very smart, but there you go. Okay, so that's the end of that one.